Stats, this is notes for 8.2. We're going to be working with confidence intervals with proportions today. So we are still looking at those three main conditions before we do anything with a population proportion. The first one is an SRS. So we're looking for something to actually state that it's an SRS, where you're actually going to say SRS is stated, or we will take randomly assigned, and that would really only be used if we were talking about an experiment, right, where they'd be randomly assigned to different treatment groups, right? And then we have the normality one. This is for the proportion. So if you remember the normality for the proportion, that was the one that was called the large count rule. And the large count rule was the one that said n times p had to be greater than or equal to 10, and n1 minus p had to be greater than or equal to 10. And then we have the independence, which we know as the 10% rule, and that's the one for 10, little n has to be less than or equal to big N, where we normally know little n, and we say it seems reasonable that big N would be more than that, right? So just reminding ourselves what are the main conditions we're working with. All right, so the next part is actually writing up a confidence interval. Okay, so we're going to draw an SRS of size n from a large population where we don't know the true proportion of something. So we're going to create a confidence interval and say we believe that the true proportion p is between these two values, right? And again, the percentage of confidence is going to be related to our negative z and our positive z. So again, just a quick reminder here that if they tell us we are doing, let's say, an 80% confidence level, then we are looking for 80% in the middle. The remaining 20 would be split with 10 on each side. And we could get to that z-star score by doing inverse norm of 0.10, and then that would give us our negative and our positive z. Right? Okay, so let's go to the whole formula that's going to give us the entire confidence interval. So that's going to be our first guess. So that's going to be a p hat because we're going to get that from our sample. Then we're going to do plus minus. Then we're going to do a z star times the standard deviation for that proportion. And the standard deviation for a proportion is going to be p hat, 1 minus p hat over n. Now, if you remember when we did this before in chapter 7, we were using the actual p-values here. Now, because we're taking a sample, we're going to use the sample amounts instead. All right. So remember that margin of error, or called the margin of variability, or just variability, is everything after the plus minus. It's the z star times the p hat, 1 minus p hat, all over n. And if I wanted to just look at the standard deviation of my sample, that's called standard error, right? So that's just of our sample, that's just the square root part. That's the p hat, 1 minus p hat, all over n. Cool, so that's the main formula we're going to be working with. So let's do an example together. Okay, so in this example, Mrs. Copper's class took an SRS of 102 pennies and discovered that 55 of those pennies were more than 10 years old. Calculate and interpret a 99% interval for the true proportion of pennies from the collection that are more than 10 years old. So the important numbers I'm getting here is I'm going to be using this 102, that's my n. The 55 is going to help me come up with my first proportional guess, and I need a 99% confidence interval. So those are the main pieces that we're going to be using. So the first thing I want to do is we want to go and figure out what the z star is going to be and what my p hat is going to be. So basically I'm using the numbers in the problem to help lead me in the very first couple things I'm going to do. I'm going to do that kind of small off to the side. So on those, let's do, we have a 99% confidence interval. So 0.99, split it in half leaves me 1%. That's going to be 0.005 when I split it. So I'm going to be doing inverse norm of 0.005 to give me my z star score. And my z star score is going to be 2.576 when I do that. Okay. Then the other thing I need to calculate is my guess. What is the proportion based on what I have? So what I have is 55 out of 102. And when I turn that into a decimal form, that's going to be 0.539. Okay, so that's the first two bits, is just giving me the numbers I'm going to need for the problem. The main structure that we're going to do, remember, is we're going to follow this idea of the words panic reminding us what to do. So let's start walking through that one together. So capital P stands for what your parameter is. So in our case, we're doing a proportion problem, so we would use cursive P or where the pi would be. And we're going to say we are trying to find the true proportion of pennies. And what is our world? What is our population? It looks like in this collection, that are over 10 years old. Okay, the next one is going to be A for panic. These are our assumptions. Those are those three conditions we started our notes with. So we're going to write them here again. We're going to look again. Here is the SRS, so we can just say SRS is stated. So we're good there. Put a little check mark. Okay, then our next one is it normal? So normal question mark, and to do that I have to do the NP is greater than or equal to 10, and let's check that one out. That would be 102 times our proportion, which is 55 over 102. Did you notice what just happened there? Those 102s are going to cancel. Have to be more than or equal to 10. That's going to be 55 is more than or equal to 10. We're good on that side. And on the other side, we're going to do 102 times the remaining amount. That's going to be 47. Notice what happens there too. The 102s cancel out and we get 47 has to be more than 10. Okay, so it passes normal. The next one is our independence or 10% rule. Okay, so that is 10 times little n, which was 102, has to be smaller than or equal to big N. So that is saying we have 1,020 pennies or more in the population. So we would say we think it's reasonable to assume there are more than 1,020 pennies in this collection. Okay, so there's the A of panic. So we've still got 3 more steps to go. All right, next step, N. We are going to name this. So ultimately, this is a confidence interval, but there's a few extra words we want to put in here. Remember, right now, this is a one sample. We're not comparing like their collection to another collection. So this is a one sample. It is a proportion. So I'm going to say it's a proportion, or at least abbreviate. And then I'm going to say what my important letter is, because eventually we're going to be using stuff other than Z. So I'm going to say that this is a Z and an interval. So we're going to be doing intervals and tests. Tests come in chapter 9. So we want to make sure they know this is a confidence interval. Okay, so that all goes into the name. How many samples, whether it's proportions or means, and then whether it's a Z interval or another letter that we'll learn in the next chapter. Okay. All right, so next step, what comes after this? Let's go and do the I. The I is actually the interval. This is where all the math happens. So we're going to go and grab that exact same formula that we wrote before, and we're going to plug in the numbers into it. 1 minus p hat all over n. Okay, so if I do that, I will get 0.539 was my guess, plus or minus 2.576. And then I'm going to put in my numbers for p hat was 0.539. 1 minus that would be 461 all over 120. Yes, 102. Okay. All right, and then after this, I'm going to go and find the point estimate. I'm going to figure out what that number is after the plus minus sign. So in my calculator, I go 2.576 times the square root of parentheses for the top, 0.539 times 0.461 divided by 102. And I am getting 0.539 plus or minus 0.127. Okay, and then I can turn that into an actual interval. If I subtract 0.127, I'm going to get 0.412. And if I add 0.127, I'm going to get 0.666. So what does that mean? That means that I'm confident at that level, right? Because I use the z-score for that level. I am 99% confident that the true proportion of old pennies in this collection is somewhere between 41.2% and 66.6%. And I'm basing that off of my one scoop that happened to be 53.9%, right? So I'm starting with what I think my guess is, and then I'm putting a buffer on either side. And the amount of that buffer is going to depend on how big the confidence level is. The bigger the percentage of the confidence level, the more that spread will be moved away from that middle guess. Okay. All right, so that's the main parts there. That's not too horrible, I hope. All right, so the next part is C. This is our last step, and this is conclusion in context. So this is a set sentence that we want you to write for confidence interval. You are always going to start with, we are 99% confident, or whatever the percentage is, that the true proportion, so I'm repeating what I had in step P, that the true proportion of pennies in this collection, you're actually going to rewrite that entire thing that you wrote at P, in this collection that are over 10 years old can be captured or contained or found in the interval. And then you're going to write it out for them, the low and the high of the interval, in the interval from 0.412 to 0.666. All right, so our conclusion statement in context, it's got to say that that confidence level should capture the real proportion. We're 99% sure that it will capture the true proportion. And we think the interval is somewhere between 0.41 and 0.67, right? Okay, but we're going to repeat in context, which means we have to be talking about pennies again, and that it's a proportion problem. So it's easier to just write out that capital P section in the beginning, and then you can steal it for part of your conclusion statement, okay? It's got to be this specific. Got to see all this work in there, okay? All right, and then it says, is it plausible that exactly 60% of all pennies in this collection are more than 10 years old? So they're saying, if you found out that the true proportion is 60, would you be surprised? Is that possible? So we would say, sure, it's possible because our interval included 60%. So we would say yes, since 0.60 would be found in our 99% confidence interval. From 0.412 to 0.666, it would be plausible, right? So I'm saying, yes, it would be plausible since that number would be found within our interval. If they asked us, is it plausible that it would be 20%? I'd say not based on our numbers, it's not plausible because we're 99% sure it's over 41. So a 20 would be really implausible. We'd say no then if it was outside of our interval. Okay, so that's a common ending after you calculate an interval, is for them to say, hey, if you found out this was really the number, would you be surprised? All right. And then just like we did in the first section, we're going to be finding some sample sizes, working backwards to figure out how big our sample size should be. A lot of this is the exact same wording as what we had in section 1. A couple things I want to draw your attention to is, again, if we're not given a number to work with, right? If I'm trying to find out what the sample size is, I actually can't calculate a p hat. I'm missing n. So what do I do if I'm missing n and I can't create a p hat? So the biggest thing here is any time where you cannot calculate a p hat, we're going to just throw in a 50-50. proportion. That's going to give us the largest possible sample size. So it's going to overestimate it for us versus trying something else that might be smaller. Okay, so anytime we don't know what p hat is, we're going to throw in 0.5. All right, so let's show an example where we calculate this one backwards. So here we go on this one. Example 2, suppose you wanted to estimate P, which is the true proportion of students at your school who have a tattoo with a 95% confidence interval and a margin of error of no more than 10%. So I'm getting 10%, 95% confidence, how many students? So they're asking me to find N. Okay, so again, for this one, we're going to start out with, we have a 95, that's going to help us find a Z-star score. So let's start there. So if I have a 95, that leaves me 5% to split. That's going to be 2.5% on either side. That's going to be inverse normal of 0.025. And that's going to give me a 1.96 as my Z-star score. So it's either negative on the left side, positive on the right. That's why we call it Z-star. And just say the distance is 1.960. Okay. All right, so from there I've got a Z-score. Next thing is they said the margin of error. So what is a margin of error? So the margin of error is the Z-star score, anything after the plus or minus sign, right? So it's the Z-star score, and it'd be P, but I don't know what P is. It'd be P hat, but I don't know what P hat is, so I'm going to substitute in P instead over N. And then we're going to start filling in what we do know. We know that the Z-star score is 1.960. We don't know what P hat is, so we're going to use our standard 50-50. We don't know what N is, that's what we're trying to solve for, and they're saying within 10%. So that goes out here. Okay, and they said it should be less than. So our calculation that includes N needs to be less than. So the symbol goes that way. All right, so on this one, notice that N is stuck in a denominator and under a square root. So one of those we could fix really quickly. We could either divide over the 1.96 and the 10, or I'm going to go ahead and square both sides. So I'm going to square everything so that I get rid of that square root sign. So I'm going to square this, I'm going to square this, and I'm going to square this. So that's going to give me 0.10 squared, has to be bigger than or equal to 1.960 squared. And then times 0.05, or sorry, 0.5, one more, 0.5 over N. Because if I square a square root, right, the square root goes away. All right, now I'm going to try to solve for N. It's in the denominator. I want to fix that. So I'm going to multiply both sides by N. Now the N's cancel and I'm left with an N on this side. Then I want to get rid of my 0.10 on the side with the new N on it. So I'm going to divide by 0.10 squared, divide by 0.10 squared. So those are going to cancel. All right, and now I'm left with N has to be greater than or equal to whatever 1.96 squared divided by 0.10 squared multiplied by 0.5 times 0.5, or actually 0.5 squared. Okay, so we're going to go grab our calculator, figure out what that amount is, and we should be getting a 96.04. So again, we want to make sure we answer the question, how many students should we survey? Well, if they're saying I need to be above 96.04, 96 is not going to cut it. I need to be above 96. So I would say we should survey at least 97 students, right? So the smallest group that I could survey and make this work within that margin of error is going to be 97 students. But yeah, I could certainly do more, and then for sure my margin of error would be within 10%. Pretty straightforward, using a lot of formulas here, a lot of template of just always do this types of stuff in 8.2, which is about proportions and confidence intervals. All right, that's it, you guys. See you later.